Okay, so welcome back to 3.5. And so I want to look at some more problems. And it says a compound containing an unknown ion X has a chemical formula of XCl2. X contains 20 electrons. What is the identity of X? And so it gives us a couple choices here. So let's look at our choices. And so we're going to see why this is our answer. And so what I want to do is, first of all, just look at 20 electrons. It's an ion. And so getting my pen ready here. First of all, with Cl2, chlorine has a -1 charge, which means that X has to have a +2 charge. And that's because the two chlorines, each having a -1 charge, have to add up to a charge of 0. So X plus 2 Cl's must equal 0. And each Cl has a -1 charge, each chlorine. So 2 times the -1 is a -2 total, plus X equals 0. So X has to be a +2. So if I look at the periodic table and use the information that it contains now, this ion contains 20 electrons, which means that it used to contain 22 electrons, okay? Because a +2 charge means that you have lost 2 electrons. And so the ion has 2 less than the original atom. And so if you're to look up on the periodic table what element is number 22, you would see titanium. And so titanium is element number 22, and it has a +2 charge because now it doesn't have 22 electrons that it originally had. It now has 20. Now, if we're looking at doing our ions here, it says a member of the alkali metal family whose stable ion contains 36 electrons forms a compound with bromine. What is the correct formula for this compound? Okay, and so first of all, alkali earth metal family. That's group 2. Okay, and if you don't recall that, look back at your chapter number 2. So if we're looking at the periodic table here, it is this family, group 2, and it says that the ion has 36 electrons. Now, if you're in group 2, that means you have a +2 charge on you, which means you've lost 2 electrons, which means originally you had 38. And so if we look at what chemical had 38 electrons initially, that's strontium. And so strontium has lost 2 electrons. Now it has 36. So it is a +2 charge. Now the bromine is located over here in group 7, and the group 7 elements, remember, are always a -1. So if we want to look at the formula for this, let's swap it. So strontium now is the 1 and bromine is the 2. Drop it for our subscripts. So strontium now has the 1, bromine now has the 2, and reduce it. You can't reduce the 1 and the 2, okay, to any smaller number. And remember, when we're looking at writing formulas, we don't ever have a subscript of 1. It's just implied that if we write down the symbol, there is 1 of that particular atom. And of course, if we want more than 1, we do have to use a subscript. So it is SrBr2. And so here are some choices, but it would have been the strontium because of the 38 electrons that needed to be in there. Now the swap, drop in, reduce rule, this one is dealing with what is called a polyatomic ion, which we're going to get to in a little bit here. But polyatomic ions mean many atoms. And so the phosphorus is with 4 oxygens, and this -3 charge is over the whole package. It's kind of like a gift basket, where you may go to the store and there may be a basket and it may have, you know, some Starbucks coffee in it. Whoops. And some chocolate bars, and then maybe a coffee cup, and, you know, some snacks and things. And then they put all that cellophane over the top and put a little bow on it. Okay? Well, all of the phosphoruses need to be together. And so the phosphorus and the oxygens need to be together in this ratio, 1 phosphorus to 4 oxygens, and then the whole package here has a -3 charge. So if we're looking at calcium plus 2 and the phosphate, which we'll talk about how we get that name in a little bit, has a -3, we can swap it, drop it, and reduce it. So the calcium will have the 3 above it, and the phosphate will have a 2 above it. Now we'll drop them. Now, with gift baskets, let's say we have coffee, a coffee mug, some chocolates, and some snacks in that gift basket. If that basket were to fall over and this was not all contained in cellophane, some of the stuff out of the basket would fall out. So we want to keep all of the ingredients of the basket in. And we want to do that with the PO4 also. And so in order to do that, we're going to put parentheses around the phosphate ion, kind of like we put cellophane around a gift basket. So that if we want 2 gift baskets, we need to have parentheses around them and say, all right, we got gift basket number 1 with PO4 in it, and we got gift basket number 2 with PO4 in it. And so we're going to put some cellophane around that so that if they were to tip over, their ingredients, their coffee cups, and snacks are not going to fall out. So when we reduce, or when we drop, we'll get 3 calciums, and we need 2 of the entire phosphate group. Now, we have not shown parentheses before because you only need them with these polyatomic ions, these gift baskets. And so if we look back at the previous slide here, we did not put parentheses around the bromine because it's only bromines that we're taking 2 of, not bromine plus some other stuff. And here it's phosphorus with some other stuff. And so that's why we need the parentheses. And so we'll look more into that. Okay. Now, naming inorganic compounds, you're going to want to read this as well as listen to the video. Now, this goes through oxidation, or the charges that most things get. So +1s and +2s, group 1 and group 2. With the halogens, they're typically a -1, -3 for group 5s, -2 for group 6s, things like that. Now, this just goes through some pictures on how to name things. And so the cation is always named first when we're naming an ionic compound. And what we're going to do is we're going to be looking at type 1 ionic compounds. And what that means is that the cation only has 1 charge associated with it, meaning it's always a +2 or always a +1. It doesn't have multiple charges, because what we're going to notice and later on is we may see that copper could have a +1 charge and copper can have a +2 charge. There are 2 different charges that copper can have depending upon what it bonds with. And so that would be called a type 2 ionic compound, where your metals have more than 1 charge that they can possess when combining with something. So the cation always takes the name from the element. So we're going to do that. And then the anion will be taking the first part of the element name, the root of the element name, and adding IDE. So for example, if we look at carbon with the -4 charge on it, okay, carbon, we're going to take the element root, CARB, and then add IDE. So this is called the carbide ion, okay, when it has a -4. If it was carbon +4, a cation, it would just be called the carbon ion, okay? So they're different. Ide means I have a negative charge, okay? And I'm all by myself, meaning that carbon is not combined with another element, okay? So here you'll have sulfide, sulfur -2, okay? Sulfide. The element root then for sulfur, and these are just kind of historical, is going to be sulf. Oxygen, the element root is ox, so this is why it's called oxide. These ones are pretty easy. Fluorine, just get rid of INE and add ide. So chloride, bromide, iodide. And these are just some of them you'll just have to practice, like phosphorus. So if we have P-3, we're going to take orus out, and it's called the phosphide ion, okay? Now, type 1, some examples then from group 1 or group 2. We're naming the cation first and the anion with the element root plus IDE. Now, the IDE says that there's only one type of element then that has the negative charge. Even though there's 2 bromines here, it's only bromine. It's not with something else. For example, if we had something like this, BRO, there's a bromine and an oxygen, and so you cannot use the IDE ending for this thing, okay? Now, type 2 metals, okay, are essentially transition metals, okay? They can have more than one type of positive charge. And so the charge on the ion has to be specified. You need to tell someone. And so in order to tell us that, we're going to use Roman numerals, like 1, 2, 3, 4, 5, 6, all the way up to 10. Okay, usually we don't have charges bigger than 6. And these are the charges on the metal ion, and they're always positive. Metals always lose electrons. Cannot tell you that enough. And so transition metals, if they're found here in the periodic table, and there's a couple other ones over here that we'll look at, will usually require a Roman numeral in the name. So some common ions, iron can be a +3 or a +2. Copper can be a +2 or a +1. And again, don't memorize what charges they can have, because I'm going to actually show you a way to figure it out. Cobalt, lead, tin, these are not found in the transitions. They're actually found over here, lead and tin, but they do have the Roman numerals behind them. And then historically, there were names such as ferric and ferrous. So this would be ferric, and this would be ferrous. Those are historical names. We try to move away from those. And so I say omit the historical names. You don't really need to know that. We're going to use these Roman numerals. Now, you should know, and there's a star on here, that zinc only forms zinc +2. And so you can write zinc +2 or 2+. It doesn't matter. They're both correct. Cadmium only forms +2. And the silver will only form a +1, okay? Sometimes we call it the silver 1 ion, but most of the time we don't call it that. We just call it the silver ion. Now, in order to do that, then, you're going to name the cation, put the parentheses on, and then use the element, the nonmetals anion root plus IDE. So the cation is always named first. The anion is always named second. If it is a metal from the transition metal that needs to have a Roman numeral, you'll have to add that, and it will always be in parentheses. Okay? So an example here is copper bromide. Now, it's called copper 1 bromide because we've got copper and we've got the bromine, and so the bromine is the negative ion. It's -1 according to the periodic table. So you will be able to calculate what the charge on the copper is, because when these add up, they have to equal 0. So by default, copper has to be a +1. And that's why it says copper +1 bromide. Now iron here, sulfur is a -2 on the periodic table. And again, go back into chapter 2 if you don't know this. It's in group 6. And so it's 2 boxes away from being like a noble gas. So it will gain 2 electrons. So it has a -2 charge. So by default, to add up to 0, iron has to be a +2. And that's why we have a +2 in parentheses. Doesn't tell us how many atoms are in the formula, because right now there's only 1 atom of iron in there and 1 atom of sulfur. But it tells us the charge on the iron ion. Now lead here, oxygen's a -2 because it's found in group 6 also, but there are 2 of them in this balanced formula. So 2 times the -2 charge, they got to equal up to 0. The charge on lead then, because what number plus a -4 is 0? You'll see it has to be a +4, and that's why we have lead 4 oxide here as our name. So metals that have more than 1 charge that can be associated with them. So that's all the metals in the transition metal land except for zinc and silver and cadmium. Okay. We'll need a Roman numeral. And remember, lead and tin, which are over here, do also need the Roman numerals. So that's